Splashdown in the Pacific. Orion has safely returned its 4 astronauts to Earth after a thrilling adventure around the moon. If you don't have $4 billion to go to space, don't worry. You can now get there for Virgin Galactic's $750,000 ticket.
You get a spacecraft, you get a spacecraft, and you get a spacecraft. Everyone this week is announcing new spacecraft buses to serve a variety of different sectors in the space industry, with Apex announcing their high-powered Comet bus, Vantor announcing their high-resolution Earth observation buses, Vantage and Pulse, and Albedo announcing their VLEO bus, Vicinity.
Your compass won't work in space, but don't worry, you'll never get lost again. The Department of Defense has spent $1.8 billion this week on space domain awareness satellites across 14 different companies. The Andromeda project is growing and is there rapidly. If they can't find you, don't worry. Lockheed's new GPS system just got a $105 million contract from the Space Force.
Welcome to this week's episode of Space Times Podcast. As always, I'm Harrison Lambert.
Here with Paul Mayer.
Excited to share this week's space industry updates with you. We hope you enjoy the episode. Subscribe to our newsletter if you want the written breakdown of our episodes emailed to your inbox every Monday morning. Drop us a comment on our LinkedIn or Blue Sky with anything you enjoyed or would like to see. And as always, listen weekly on Spotify, Apple Podcasts, YouTube, Substack, or wherever you're receiving this.
As a quick additional note, we'll be at Space Symposium this week. So reach out to us if you'd like to meet up in Colorado Springs. So this week on Space Times, we've got a bevy of different things to talk about. First and foremost, Artemis 2. We launched, we made it to the moon, we made it back home. We're so excited to talk more about that, but we've got some major updates all centered around Artemis with regards to human spaceflight. Then there have been a bevy of different progressions and updates out of Spacecraft. As Harrison alluded to, there's a multitude of different buses that have been announced and a multitude of different layers of capabilities that we're excited to talk about. And then there's an additional $2 billion plus of different defense contracts that have been announced over the coming year. So plenty to talk about there, as well as a multitude of different business updates and a few tech advances to hit on. So to start us off here, Artemis, a textbook success from end to end. The launch was awesome. The launch went off without a hitch. I think the only reported issue that either of us really saw was the toilet, the plumbing. And that was just, all we had to do was roll the darn thing and get the plumbing in the sunlight to unfreeze some frozen stuff. But the fact that this is the first toilet on space, only one problem is pretty good.
Yeah, so you can learn something from the astronauts. If you're having toilet problems, just take it out into the sunlight and you'll be all set.
Textbook success end to end. Great to see. It was really impressive and honestly a little bit warm and fuzzy to see the Integrity capsule with the flotation devices, with the parachutes back there. Like, great to see that again. It's been a very long time.
Yeah, you last time or something.
Yeah.
Wow, back in 1972.
Yeah. It's been a long time since I've seen Apollo 13.
Yeah, okay. Same thing. This is the first in our lifetimes, man. It was a real interesting moment. Like my dad remembering back when Apollo missions were going, and for us to have a mirror moment here with Artemis, it feels a really cool bridging of the generations. And at least I know in my family, everybody was excited for the first time about space, as opposed to all the other times I gabbed their ear off about all the stuff we find cool. Right. But the podcast is usually my outlet for that. So for once to be able to nerd out about some cool stuff in space was really great. And I think that was one of the core purposes of Artemis, is to get people excited about going to space again. So yeah, mission accomplished on that front as well.
Absolutely. Artemis 3, I believe, is scheduled for 2027, which is the in-orbit sort of rendezvous multi-vehicle mission. Artemis 4 is boots back on the moon, scheduled for, if memory serves, 2028. So hopefully there's no schedule slips there, and we're able to stay on task and deliver to those milestones. But super excited to see the Artemis program continue to grow and make progress here.
Yeah, I think Artemis 3 is supposed to drop off some rovers on the moon, which we've seen a lot of investment from CLPS recently. So hopefully some new players are ready for that mission as well. I know China's rearing at it. They just got the Chang'e ready and loaded up for their mission to the lunar South Pole. So, with this kind of starting gun of Artemis 2, I think we're going to see a lot more missions flying to the moon very soon, especially with this yearly cadence that NASA is going to be targeting moving forward, even with their reduced budget.
Yeah, 25% reduction in budget while I believe stepping up the timeline for what they want Artemis 2 to accomplish is really impressive. I know a multitude of different folks in NASA throughout different departments who were all thoroughly impressed and surprised that Artemis 2 actually did launch on April Fool's Day. The mentality was like, oh, something's gonna push it back another month, but
I think
we made it.
Yeah, I think NASA just loves trolling the conspiracy theorists. This is just another move.
You might be onto something there. Friend of the show, James Skalkvik, wound up the CEO of Azora, wound up catching the signal from the Orion capsule as it's rounded the moon. He and his team managed to do that out in the desert, I believe. Was that in Arizona or California?
California desert.
Yeah, so up in the high desert in California, they managed to capture the O2O signal from the Orion capsule using their mobile ground terminal. So they literally drove out to the capture zone, set everything up, did so in a matter of hours, and they weren't able to decrypt anything, but they were able to receive the signal. So they got, figuratively speaking, they got a static rather than just a black box. But super impressive accomplishment.
Yeah, I thought that was super cool because we talked about the OTO last week and we had a little tech advance because I was excited about second furthest laser optical communication after the same OTO system communicated with Psyche about a year ago.
The distance of the communication with Psyche?
That was about 1.2 million miles. So the moon is a meager 140 million or 140,000 mile.
Yeah, 150,000 miles versus 1.2 million, but still really cool.
Yeah, it still gave NASA the top two spots in record distance communicated over laser. China got the third with GEO, although NASA's kind of neck and neck there too, because as James explains to us in our interview, there's a GEO laser communications kind of demo satellite that they were using to test their equipment against. So there's a lot of competition for GEO to Earth communications, but Moon to Earth, this is the first opportunity with Orion, and they leapt at it 2 weeks to get their equipment fitted to handle this communication, and the drive into that 6 kilometer range to just pick up on the signal is super neat. Puts them at third furthest communication over laser behind NASA. So great accomplishment there. Really, really cool proving of their technology.
So we're going to jump over to some excerpts of our interview with James and the team, and we'll be right back. Well, today on the Space Times podcast, we would love to welcome James Skalkvik and Philip Belskop, the CEO and Chief Science Officers for Azora Space. We're very happy to have you here, and we're so grateful to get the opportunity to chat with you and ask you some questions and hear all about some of the amazing progress that you've made, and most importantly and most impressively, the fact that you were able to actually receive signal from the Orion spacecraft on their recent whip around the moon.
Yeah, all right. Thanks very much, Paul. Yeah, really thrilled to be here. Great to be here.
What is it that Azora Space does? What do you do?
Azora fundamentally is building high throughput communications infrastructure for environments where fiber can't reach. Now we're starting with space, which is one of the hardest hit areas for this. We've relied on RF communications from space for the last 50 years. And that technology just hasn't kept up with what we've been doing on the ground, laying fiber optic cables, getting to terabit speeds around the world. And particularly in our increasingly networked world that relies so heavily on immediate access to large amounts of data, this seems like an update that space is really overdue for. And it's exciting today, particularly because we're seeing space turn into kind of a network data layer already. We're launching more satellites than ever. Sensors are improving, constellations are proliferating, and more of them are already being connected using intersatellite optical links. But the ground segment just hasn't fundamentally changed in decades. The infrastructure we build today scales linearly, and it's hitting these spectrum and throughput ceilings. So today it's easier to launch a satellite than to build a traditional RF ground entry point. And optical solves that throughput problem, and it does for space what fiber did for terrestrial networking, which allows data transfers at 1,000 times faster rates than radio without any of the licensing issues.
just this week you communicated with the moon. I think I saw elsewhere that you had prior to that you communicated 50,000 kilometers. So what is kind of the trajectory you're following to scale out your solution?
Our first demos that we did, which were from sort of December through February, were still ongoing, were with the NASA Laser Communication Relay Demonstrator Satellite, or LCRD, which is a geostationary orbit satellite at about 36,000 kilometers, so about 10 times closer than the moon. And those tests were done to sort of validate our technology and our sort of concept, where we were using very low cost optical systems with relatively small aperture sizes, so that we could get around needing very fancy systems to deal with the atmospheric turbulence issues. And so making all of the optics, as simple as possible, and then putting as much sort of our effort into making the detectors as sensitive as possible. And so we validated that. We had great data coming down from LCRD. We downlinked data up to their maximum data rate that they do incoherent data downlink at 720 megabits per second with high signal to noise with a 25 centimeter aperture, which is smaller than anyone else had done before. And then the O2O was just an opportunity that we thought, it would be amazing if we could just give it a shot and see if we could see that signal as well in a small aperture system. And it was kind of a last minute, that was a moonshot, or as James called it, a moondoggle, because we packed everything up in my Volvo and drove out to Table Mountain and we set up and basically did it all in like one day. I mean, we were only really on sort of pointing at Artemis for about 2 hours.
One of the reasons we decided to go with the kind of form factor and cost that we're aiming for is because the way that optical works at scale is going to be a sort of proliferated, global, geographically diversified network. Because what that does is it allows you to get around the concerns about clouds. If you have 5 or 10 terminals around the world, potentially, a third of them at any given time could be covered by clouds. If you have 100 terminals, it doesn't really matter as much any longer. If you miss a pass because one's covered in clouds, there'll be ability at the next one. But it also, once you've got that scale, means that if you have 100 terminals, any single satellite in LEO is passing over a terminal on average every 20 minutes. And if you can do tens of gigabits per second downlink, you're really transforming the way that we communicate with space. So the primary business model is not selling units. Our work with the Defense Department might involve actually delivering units for them to deploy, but the commercial roadmap is deployment and operation of a global network.
What's your ask in closing here? What can we or our audience help you out with? What do you need today? What do you need tomorrow? What are you looking for?
Sure. Well, I think the real message we're trying to get out there is that optical is open for business, and it's space to ground is doable today, and it's doable for LEO all the way out to lunar. And as I mentioned earlier, lunar customers are some of our earliest targets. If you've got a mission that is bandwidth constrained, and I would say that's pretty much every lunar mission, we'd be really interested in talking about supplying you with hundreds of megabits to gigabits of data from the moon in the next couple of years. We are also we're expanding our team. So anyone who's interested in working in this field, we're based out of Phoenix and San Francisco. So we'd love to chat to any smart people who want to work on a hard problem with some great people. And we're partway through our seed raise. So if you're interested in getting a piece of it, I'd love to chat.
And we'll be at Space Symposium next week. If you're there.
Well, Paul, I look forward to meeting you guys there again. And thank you so much for joining us on Space Times and telling us all about the amazing work of Azora Space.
Cool. Thanks very much for having us.
Yeah, it was great. Thanks.
Super grateful again to James and Philip for joining us and sharing about what they're working on and all the progress that they made over there. They have grown very quickly over the past 8 or so months. So they're really taking off here. Speaking of taking off, we're also happy to talk about some of the updates from Virgin Galactic. So they've unfortunately raised their ticket price, but their ticket price is now $750,000 in order to get to space.
Darn, did they price you out, man?
They did. They did. I was right there. I was on the wait list, but so they've come back from a 2-year launch pause, and they've raised their tickets up from about $250,000, up from 200,000, 250,000. So they claim that Unity flew 60 people across a dozen flights before its retirement in 2024. Now, Unity is a 4-seater. So by my math, they've had a handful of people sitting on laps to hit 60 in 12 flights. But
maybe that's how we fly. We can split the 750 ticket.
If you got a hat, we might have a crack at this. But their Unity vehicle is going to be replaced by Delta, which the name makes sense because Delta V is very important. But at the same time, somebody at marketing may have phoned it in for a little day, because it's going to be very hard for me to separate the Virgin Galactic Delta vehicle from my experiences with Delta Airlines, which may or may not be fabulous. Who's to say?
Do you think the website Delta Airlines is available? They can get that, sketch that up.
Yeah. Maybe that's how we get in. We buy the Delta Airlines site, and then we flip it to them for a couple of seats. But Virgin Galactic lost almost $280 million in 2025, which is a massive improvement from the $350 million they lost in 2024. So to date, they've sold over 500 tickets. I think almost 650 in total. But so, commercial spaceflight and private spaceflight still very much a little ways off from that business loop totally closing. But it's good to see that Virgin Galactic is back, and that they're still in the space and haven't totally exited after that 2-year hiatus.
Yeah, I guess it's good they took a break. I mean, a lot of times when you're developing new spacecraft, it helps to not have to be operating while you're doing block improvements. So it sounds like a couple of years was enough for them to upgrade from Unity to Delta. Delta has a lot more reusable parts, so that's why their maintenance time reduces down to under a month. That's like half a week to refurbish it and get it flying again, which is an impressive improvement over a month. And just the part design of it also allows them to mass manufacture. So it sounds like they're positioning themselves to build more of these and at a larger scale, which should also, I doubt it will reduce the ticket price, but it'll probably improve their profit margin. So great improvements to that. It's going to be a bit challenging still this year, even when they return to flight. A lot of those 650 tickets are already sold at the lower price points, so they're going to have to fulfill those obligations before they can start charging the higher prices. But yeah, great to see them going back to flight. On the spacecraft side of things this week, we have some big announcements coming out around the world. To start, we're going to talk about 4IG, which is a Hungarian space and defense company. They announced a number of contracts. Actually, a couple of them are relevant to the space industry, but they also had some others related to just defense industry as well, since there was some visit for the U.S. government and announcing a bunch of partnerships between the two countries. The big one is Northrop Grumman's HuGeo contract for 4IG to deliver a Ka-band GeoStar 3 satellite. This is a multi-million-dollar deal that it didn't disclose the exact amount, to deliver the first communication satellite for Hungary. So this is the first sale of the GeoStar for this year. I think it's only the third in total for this specific application for a GeoCom satellite. It's the same bus they use for the MEV and the MRV, which are the RPO mission extension vehicles that Northrop Grumman builds as well. So, great. They've got another sale for this. Great for Hungary, which through 4IG seems to be growing pretty rapidly. We talked about them back in December when they signed it. They gave like $100 million to Axiom Space. And we were really questioning what that was for. I hadn't really heard of 4IG before. But then in January, it turns out that part of that was to put 2 data centers up in space. There's 2 Axiom data centers that were going up on Kepler's Tranche 1 constellation of laser interconnected satellites. So this company, and I think Hungary in general, is making some big moves to boost their own sovereign space capability, because all this seems outside the scope of ESA, although they are an ESA member state. So it's kind of a trend we're seeing where, a lot of these countries will contribute to ESA to European space capabilities, but simultaneously spend a lot of money on their own. So the second relevant part of this is that they also signed an MOU to Apex Space for a constellation of satellites. So this is their constellation called HuSat. And to start, it will consist of 8 Earth observation and synthetic aperture radar satellites. The payloads will be developed by 4IG SDT, but the buses will be coming from Apex under a joint venture that they've established to develop these spacecraft. So really interesting to announce these in combination. It's similar to what we've seen with some other companies, kind of like when we talked to Open Cosmos, and their CEO Rafael was telling us about how Connected Cosmos was intended to connect their open constellation through this communications layer. It seems that this geo communication satellite might act as a sort of backhaul for a lot of these Earth observation satellites to try to tie together a lot of this data and communicate it more rapidly to the ground for some defense applications and rapid observation applications.
Yeah, I'd be curious as to the timeline more specifically for HuSat and what classes of buses they're looking at acquiring from Apex. Apex just announced, I want to make sure I'm getting this right, but so they've got Comet, which has been around for a little while and is rated for 5 kilowatts. They've got Nova at 1 kilowatt and Ares at less than 1 kilowatt, somewhere around 200, 150, something like that watts.
Yeah.
But then they've announced Comet Mini, which is 4 times larger, 20 kilowatts power, and they've announced XL at 100 kilowatts of power. So I'd be very curious as to what bus class that this particular constellation is looking at using, if they're just doing sort of Earth observation and SAR, and if they're at LEO, or if they're intended to be more in sort of the MEO or GEO, if they are going to be looking at doing that sort of backhaul for the telecommunication or for the data transfer. I'd be interested in knowing sort of where that fits in with Apex's new bus or new buses, and where that is planning to shake out. But I'd also be curious as to understanding the timeline for HuSat and when that's supposed to fit in with things, because Apex themselves has had a couple of big announcements this week as well.
Yeah, I think these are all under the 2030 timeline. And from the way they're talking about it, sounds like they could use any of the buses, and that's probably why they partnered with Apex, is because they have such a diverse lineup of buses. Because 4IG is going to be heavily involved in the overall spacecraft design. Like you said, they're developing the payload, but this is a joint venture, so it's not just Apex. They're not just buying buses from Apex. They're developing these spacecrafts under this new joint venture. Right. So any of those satellites from the lineup could be useful, although I'd imagine it's going to be on the Ares side, definitely for Earth observation. For SAR, I can maybe see them going up to Nova, but I don't see why they would want Comet for any of these, unless they expect to expand out their communications network beyond the huge GEO satellite that they just bought. So very interesting partnerships. It seems like they did with Axiom, they're trying to tie themselves more closely with United States space capability, both to benefit them from our technology and maybe also just accelerate their timeline to deployment. So as Paul mentioned, Apex has announced a update to their catalog. They are pivoting into bigger satellites. So they've long held that they're going to develop the Ares, the Nova, and the Comet spacecraft. These are ranging from 175 watts up to 5 kilowatts. So already pretty high power, but this announcement is that Comet is getting 2 variants that expand that up to 20 kilowatts for the Mini in 2028 and 100 kilowatts for the XL. These are interesting patterns that we see off the back of K2 Space launching their Gravitas platform last week. That platform is 20 kilowatts. The one that comes after is supposed to be 100 kilowatts. So this announcement from Apex seems to pit them head to head against K2 Space, which is a very interesting play to make. The 2028 timeline is makes sense given that K2 had been kind of holding off on launching their spacecraft until Starship was ready. But I think that Gravitas launch on Transporter 16 was to flush out all their hardware and make sure it was operating on orbit. So to me, this reads like Apex was waiting for K2 to kind of prove out the ability to operate at such high power, and now they're trying to capitalize on the fact that Starship seems imminent, and these large high power buses are going to be a key offering in the near future, and one that defense applications are just chomping at the bit for. And we've seen communication companies kind of grow into that extra capacity and find new applications for it.
Yeah, one thing that's sort of notable about the prioritization of high power in the buses is that, for example, the Comet Mini still has the same payload sort of mass capability. It's still able to do 450 kilograms of payload, whereas Comet, their baseline Comet is able to do sort of 400 to 500 kilograms. So the key distinction here is just the increase in power. That is what is driving the improvement here. So it's noteworthy to point out and highlight the fact that the current demands of the space industry are very much prioritizing additional operating power and the ability to support that operating power, more so than it's prioritizing or supporting additional mass or additional volume. That is the sort of key operator. So I would not be surprised to see over the next couple of years, I would not be surprised to see operating power continue to be the key factor by which we basically determine and classify satellites until we reach sort of a certain level of saturation. And then we'll start to see mass, and we'll start to see effectively launch cost wind up starting to take its place back as the most defining characteristic of satellites as well. But just notable to highlight the fact that this is a pretty substantial shift in the industry, largely to align with the defense and orbital data center needs that we're anticipating for such high power usage.
Yeah, the more traditional use of space for Earth observation, Vantor has unveiled 2 new satellites, the Vantage and Pulse. These are high-resolution Earth observation satellites, kind of like their Worldview Legion spacecraft, but this is poised more as a satellite that they can sell to other customers. So Worldview Legion was a satellite that I actually worked on a few years ago. It was developed by SSL at the time, and then they got folded together into Maxar, and now Vantor operates their fleet of Worldview Legion for 30-centimeter resolution Earth observation imagery. So this is an interesting trend that we have seen play out in a couple of other comparable companies recently. Companies like Satellogic and Black Sky, and even Planet, with a Swedish sale they made a few months ago, are starting to see some real demand for sovereign space capability. So rather than just providing imagery from their own fleet of satellites, there's been purchases out of Spain, Portugal, Sweden, for all those companies to sell the satellite itself to countries for them to operate and collect their own data. This likely plays a lot into defense implications. Defense needs are a bit different than commercial needs. They want to own their own data. They want to have secure pipelines for that data. So likely this is a play by Vantor to appeal more to defense and potential space sovereignty for other countries. It is an interesting breakdown to have 2 different satellites they're offering. Vantage is at 20 centimeters, which is actually higher resolution than their Worldview Legion, whereas 40 centimeters for Pulse is lower resolution. So it's kind of straddling either side. This could be a good kind of lever for them to pull to improve the next generation of Worldview Legion, as well as delivering this capability in a different form factor. And this is planned to roll out over 2027 to 2029. So it sounds like they've got the spacecraft all designed, and now it's just a matter of finding customers for it, which I would expect to hear about soon.
To your point, I think what's interesting to me is that so Vantor, formerly Maxar Technologies, Maxar built Worldview Legion, which has I think that's a 30-centimeter resolution, but it's already better than what they're able to provide next year with Pulse. And because Maxar Technologies was an amalgamation of multiple different companies. It was MDA and Digital Globe and Space Systems Loral. It makes me wonder how much of the actual heritage data and how much of the actual sort of tribal knowledge and engineering know-how that went into Worldview Legion actually stayed with what is now Vantor Technologies. How much of that was actually done in Colorado at Digital Globe, how much of that was done at Space Systems Loral, because if memory serves, that was basically an all hands on deck project for SSL, was getting Worldview Legion functional. So while it's in name sort of building upon the capabilities and the learnings of Worldview Legion, I'd be interested to look into and sort of poke at that a little bit more to get a sense of whether or not there actually is that much heritage data still sort of in-house at Vantor, or whether they really are more or less needing to sort of stand up 60% of the capabilities that they have from scratch for this new class of satellite. Given the fact that they're starting with Pulse in 27 and then releasing Vantage in 29, and they're going from 40 centimeters down to 20 centimeter resolution in that time, sort of indicates to me, or at least would give credence to me, the idea that they're effectively sort of staging this out and developing this as they're able to achieve those milestones, rather than just sort of arbitrarily deciding, well, we'll just do 40 centimeters and then in 2 years we'll do 20 centimeters, even though we already have the technology in the back office on how to do 30 centimeters today.
Yeah, the 20 centimeters is interesting because like it's not a technical hurdle so much, like it's more of a regulatory hurdle. So I'm wondering if if the rules are going to change by 2029, or if the fact that they're selling it to operators that could potentially be defense agencies just means that they can ignore that restriction. So yeah, interesting breakdown. I think it would be curious to see if they switch manufacturers, if Lanteris doesn't end up manufacturing these satellites for them, if instead they go and take their IP and bring it to another manufacturer. Speaking of high resolution, we have Albedo talking about their new bus, Vicinity, which is a VLEO bus. So that's very low Earth orbit. It orbits at I think 200 kilometers was their Clarity mission that ran last year and was doing 15 centimeter resolution imaging. So even higher than what we're talking about with either of the two Vantor buses, but they get that by flying at a lower altitude. So very interesting to see that they're building a bus offering off of the back of their Clarity mission, because Clarity was their own built and operated imaging satellite. And so I think this plays into the same trend I was just talking about with Vantor. There's a lot of demand growing for sovereign Earth imaging capability. To me, it's an interesting trend because it plays in contrast with the other trend we're seeing with Earth observation, which is that a lot of commercial customers don't want raw imagery. They want insights that they can actually act upon.
Right.
While we're at the same time seeing defense customers want to own the satellite even higher up the chain. They don't want just images. They want to own the satellite that's taking the images. So a lot of these companies, I see them getting pulled in two different directions. Vantor is obviously big enough that they're able to operate on both sides of that. They have their insight offering platforms, and they also own their own spacecraft, so they're able to sell them if they want to. And that's kind of what we see play out with like Black Sky and Satellogic and Planet. Albedo's a bit earlier. Like I said, they've launched one mission, Clarity. It wasn't a complete success. They had some issues with the imager resolution and just growing pains with a first flight, figuring out a domain that basically nobody flies in. But they're taking those learnings and they're applying them to a bus offering that is pretty unique in the industry. There's not many people that can offer a VLEO bus that's actually flown before. So it would be great to see what demand this drives. I think there's very few competitors. Like Redwire has a Sabres platform that they sell, and I think I've seen some other small companies do it, and Europe's been talking about it recently, but Albedo's kind of out ahead of this in this new kind of sector.
Yeah, Albedo's press release spoke about a couple of things that I thought were really interesting, sort of tying into the trend of power sort of becoming the new sort of standard metric across satellites. They included some cocktail napkin math that basically pointed out that, look, for certain payloads, the power needs of those payloads scale proportional to the fourth power of altitude. And so if you're looking at sort of like a traditional star, basically the cross-sectional area of your synthetic aperture radar itself, that is directly proportional to the power needs of the spacecraft. And the size of the SAR radar that you need scales with the square of the radius scales with the square of your distance. So in that particular payload example, ultimately you're scaling the power needs with the fourth power of your altitude and distance. And so the cocktail napkin math that they included was basically, look, at 300 kilometers altitude, you're able to accomplish with a 3 kilowatt bus what you would need a 48 kilowatt bus at 600 kilometers altitude. So they're very much looking at being able to leverage the close proximity. So I would fully expect Albedo to be leaning into the types of payloads that would benefit greatly from needing smaller, more concentrated, less cross-sectional area payloads that afford them the same sort of quality and the same sort of product that would otherwise need a super high-powered bus to achieve at even something still healthily in LEO in order to accomplish.
On the China side of things, Space T has raised $190 million and is planning their IPO. This is a Chinese space company that's focused on satellite manufacturing and kind of fits the trend, one of the trends that we've seen in China, which is building out some of the core capabilities of spacecraft production. We've talked mostly about their rocket launch capability and the rocket sites that they've been building up. They've been pouring billions of dollars into that, but they also have been putting a lot of money into their manufacturing capability. And so the Space T is a large funding round to help develop, spacecraft manufacturing, which is something they're going to need to implement a lot of their satellite constellations. Because just like the U.S. and Europe, actually more like the U.S., Europe doesn't have constellations at the scale that China's talking about. But like the U.S., China is launching thousands and thousands of satellites and actively, like right now, not just on paper. They're launching thousands of Guangzhou and thousands of sail satellites. Their Beidou constellation is very big. I think they've had like 2 different crew capsules go up. There's like 3. It was 2 Shenzhou capsules, the Mengzhou and the Qingzhou all went out in like the past month. So they've got a whole cornucopia of satellites going up across all the different applications we talk about all the time. So really building out this capability is key for them. And I think a big funding round like this makes that clear.
Yeah. One aspect of the Space T announcement that is noteworthy is that the U.S. actually sanctioned Space T back in, I believe, 2023. The intent and sort of the motivation behind the sanctions was to try and sort of slow down their development by cutting them off from Western capital because they were viewed as sort of adversarial and a potential risk to sort of American and potentially Western interests on orbit and in space. And what's noteworthy is that sort of as a result, seemingly, of that sanctioning, as a result of not being able to get access to sort of Western and more traditional sources of capital, Spacey wound up getting almost exclusively funded by the state internally. And that sort of vertically integrated funding without any sort of strings attached, that actually helped to speed up their improvement and to rapidly increase the maturity and the growth. They've gone from a company among many others looking for Western funding to now pursuing an IPO in a span of 2.5 years.
Honestly, that U.S. sanction might be more of an endorsement of the capability than anything else.
It makes sense. If they've got America nervous, they must be doing something right.
Continuing around the world and in Europe, we have Endurosat announcing a new satellite partnership with Shield Space. This satellite is called Broadsword and is planned to be launched soon in Q2 2027. This Broadsword satellite is similar to the one we talked about with Gravitics and like Aspect Aerospace last week, where there's a larger spacecraft that contains a bunch of smaller spacecraft. The large spacecraft being the host spacecraft that sends out the smaller spacecraft to do some activity. This kind of plays into the orbital interceptor arena, it seems. The demonstration is to have an 8U spacecraft with 3U chase spacecraft that it can fire for intercept capabilities. They're claiming it's RPO, but just the way it reads, it sounds much more like an orbital interceptor kind of play, which we've seen quite a few players. There were a couple back late last year, like Apex and Lockheed announcing their efforts. But since then, we've seen some more companies come out with their proposals. Like I said, Gravitics last week. So this is an interesting proposition for Europe. They haven't been too eager on this technology, so I don't know what need they're specifically trying to chase, but I wouldn't be surprised to see some defense funding for this soon. I think it is an interesting partnership. It reminds me kind of like the Victus missions over in the US for rapid deployment of space assets, because Endurosat is a manufacturing company that's kind of touts themselves as a rapid design and manufacturing company. We talked about them recently, like their partnership with Airmo. So having that capability and then to build a satellite that can then rapidly deploy on orbit, seems like they're building up this full kind of like design, development, deployment capability to move rapidly to space applications. So I'm kind of expecting them to announce like a launch partner that they would operate with soon to do something kind of like the Victus Haze or Victus Nox missions, but for Europe.
It's great to see these two working together, and the joint venture in this case does certainly make sense. So Shield Space very much is bringing to the table the autonomous RPO capabilities, and Endurosat is very much on the manufacturing and the bus side of things. They're bringing sort of their standardized approach to everything, allowing for rapid sort of turnaround and a quick solution for everything that's needed. And to your point, the broadsword demonstration is very much sort of proving out the Project Nexus that is so similar to some of the vehicles and models that we've seen out of Gravitics. So the Project Nexus is the sort of follow on and the next extension of what they're proving out here with broadsword, and it is a mothership with multiple hive ships effectively, but it's a command nodule and then multiple different independent vehicles that are able to then return to and dock with said nodule. So this, to your point, does not at all read as an RPO. They're calling the two vehicles for the broadsword demonstration, they're chase and target vehicles. It very much reads as a space-based interceptor play, and it 100% plays into the sovereign demands and the sovereign need for smokestacked space capabilities. But it'll be interesting, in particular, at least for me, to see how long this relationship between Endurosat and Shield is able to sort of maintain. Because these joint ventures are just sort of inherently unstable. They're inherently short-lived, and they're inherently not something that's able to really maintain for a long period of time. But given sort of the ambitions that we've seen established, I'd be interested to see what that actually winds up looking like in practice.
I think the weirdest thing to me about this one is that like when Apex announced their Project Shadow, it was clear that they were self-funding, and Lockheed seemed much the same, but it was like in anticipation of Golden Shield funding down the line. But Golden Shield doesn't expand to Europe, so I don't know. It's just, to me, it's odd that they're pursuing that play when they don't have the same contract mechanisms that we do in the US.
I think I would hazard a guess that they're not as concerned about whether or not the contract mechanisms exist currently. I think what they're more interested in is demonstrating that this works, demonstrating that they're able to get this capability, and knowing that at some point, if you build it, the defense industry will come.
Speaking of defense applications, we had a lot of news this week on the defense side of things. The biggest one being a $1.8 billion award for the Andromeda project coming out of the Department of Defense. So this is an IDIQ, indefinite delivery, indefinite quantity mechanism, that allows them to award up to $1.8 billion amongst a cohort of companies. So the original competitors were 32 in number. They selected down to 14. Among these 14 companies, they are now allowed to select more freely without competition amongst them to fill out the needs of Andromeda. Andromeda is a space domain awareness project for the Department of Defense. These are all space-based space domain awareness satellites. So there's already a large number of space domain awareness capabilities on the ground. We've talked about like the AUKUS consortium for their SDA capability. We did like Deep Space had an update to their network last year. But this is a growing need as we talk about space defense and contested space and adversarial space interactions, is having these capabilities on orbit to be able to have more more native and quicker response rate and better resolution and understanding of what's going on in space, so that we can task and protect our protect our space assets against adversarial interception. So the 14 companies that they selected were Anduril, Astranis, BAE, General Atomics, Intuitive Machines, Lockheed Martin, Millennium, Northrop Grumman, Quantum, Redwire, Sierra, True Anomaly, and Turion. If you'll note, we have all the big primes in there: Lockheed, Northrop, Millennium, which is Boeing. We've even got General Atomics and BAE in there. We also have a handful of smaller companies, which is great to see. We don't want all the money being funneled just to the space defense industry. Of course, Sierra, Redwire, they're pretty big, but we have smaller companies like True Anomaly, which is a pretty small space startup, but focused on space defense. So great get for them, as it'll help build out their full stack of capabilities. Probably the most interesting one to me, though, is Anduril. As we talked a few weeks ago about them buying exoanalytics solutions, at the time it didn't make a lot of sense to us because they're primarily a ground-based defense company working on drones and missiles and technology for warfighters. They have had partnerships in the past with space companies. I believe I've seen them talking to like K2 Space and Apex about some space capabilities, but this was their first dedicated like sovereign ability to do space operations by purchasing exoanalytics. So it looks like that purchase set them up squarely to service this contract, which puts them in the mix amongst a lot of other space-based players to capture some of this huge $2 billion contract. So congratulations to all those companies. It's a really needed technology, and it's great to see it broken up amongst a bunch of people that can compete to bring us the best technology.
Yeah, I mean, to your point, 32 competitors down to 14. I'm surprised by how much variance there still is in those 14 down selects with respect to the size, maturity, and like on orbit capability of all of these different companies. So like, some of these folks are the big primes that we spoke about. Others like True Anomaly and Turion are much smaller and earlier stage. So these are massive wins for those. And it's great to see there be some resilience and some I'll say like diversification of this contract already sort of like baked in. I wouldn't at all be surprised if it was like, okay, hey, we're here's the pool of all the different competitors that we've got here. We're going to select down to 14. 3 of those 14 have to be companies less than 10 years old, or whatever the number is, right? Like so many of these companies have to fit into sort of like this smaller or more innovative bandwidth. So many of these companies can be, but only so many of these companies can be companies that we would describe as like the major primes. And so like, I wouldn't at all be surprised to see something like that. What I'm much more interested in learning more about as Andromeda continues to sort of grow and develop is what the actual allocation is going to wind up looking like. Are they going to be doing dozens and dozens of smaller contracts in the smaller, meaning 50 million to 100 million in size, or are they going to be doing just a half dozen contracts each at 200 or 300 million or more? But it'll be interesting to see sort of how that winds up getting divvied out. I would expect basically everybody at this stage to have a pretty good shot at winning tens of millions of dollars in awards here.
And the other trend that's in here is Intuitive Machines and Quantum Space both got awarded, which are both their sister companies, both owned by Cam Ghaffarian. So it follows the trend that Cam Ghaffarian always wins.
This guy, we should just ask him for lottery numbers, because no matter what happens, this guy finds his way to a lot of money.
Cam always wins. That is a trend in our industry.
Cam, call us. We'd love to have you on the show.
Another award that came out of that same announcement from the Department of Defense was a $105 million contract to Lockheed Martin to develop GPS ground control. This is an interesting move, given that we talked just last week about $50 million going to Raytheon for the OCX system, which is a long beleaguered GPS ground controlled system that they deployed last year to tepid response from the Defense Department. They said that the system didn't really work, and this is after 6 years delay in deploying it. And there's been a lot of push to abandon that contract. So it's interesting to see this contract pop up for Lockheed Martin. It is kind of an expansion upon what they've already been doing. They've previously been awarded $1.36 billion to produce the GPS 3F satellites, both number 11 and 12, as well as $500 million for number 21 and 22. So they've been involved in this GPS upgrade on the satellite side of things, but this contract seems to give them an expansion into the ground side of things. It reads very much to me like they're done with Raytheon and they want Lockheed to step in and get this system going, because this system's been behind. They've had to do a lot of workarounds to make it work. They were using some military grade channels of the GPS to kind of bridge the capability they needed while the ground system was getting stood up. And I don't think they were big fans of having to do that. So it looks like they're taking a new approach to try to get this GPS upgrade finally across the finish line. And it seems like Lockheed might be the one stepping in to take care of that.
Yeah, one of the big trends that we hear over and over again from Generals Haig and Purdy is that the U.S. government and U.S. military's trend of keeping failing projects on life support, of succumbing to sort of the sunk costs fallacy, is very much a targeted area of improvement. So like, hey, we sunk so much money into making this contract succeed, we'll cut you another check to make sure that it gets going. Like, that mentality is very much changing, top down, bottom up. It's changing throughout the entirety of the U.S. government sort of acquisitions and appropriations avenues there. So I'm not at all surprised to see them seemingly making moves to get ready to cut that OCX contract loose.
Out of another defense agency, we have another large contract. The Space Development Agency has awarded $48.9 million under the Halo Europa Track 1 program to Capella Space. This is interesting on two levels. The Halo Europa program is a segment of the PWSA that's intended to be outside of the normal competition and long acquisition timelines of PWSA for each tranche there, and instead free up money for them to develop advanced technology under separate tracks. It's only been exercised twice. We talked about it back in February when AST Space Mobile got Europa Track 2 for a similar amount of money to develop tactical satellite communications. At that time, it made sense. AST Space Mobile had just deployed their first tranche of satellites. It was operating well in orbit. Tactical satellite communications fits well into their business model. So that all made sense. This one makes a little less sense, as we've been questioning what exactly Capella is doing since they've been acquired by IonQ last year. They launched a satellite last week on Transporter 16. It wasn't clear what it was for. And before being acquired by IonQ, they were a synthetic aperture radar company. This contract is for tactical satellite communications as well. So it's a satellite communications payload on board, presumably their bus that was designed around synthetic aperture radar. One of the aspects, the secure communications aspect, kind of makes sense in relation to IonQ, them being a quantum company. Quantum encryption is one of the bigger advances in RF communications. But there's other aspects to this, like advanced RF payloads and mission-specific waveforms, that's a little outside of their domain expertise. But to me, this is reading a lot like Capella is being used as an advanced platform developer for IonQ, and they're pursuing any contract that can bring in money to help progress their capabilities on orbit that can eventually be turned around and used for their quantum applications once those are ready for space. So very interesting move for Capella. They beat out 19 competitors, so they must have some secret sauce that's very interesting to the Space Development Agency. And I would be curious to see if they end up bidding on future. Well, I know they bid on them, but I would be interested to see if they actually win any future tranches of PWSA off the back of this contract.
Yeah, I think we spoke about this when Capella was. I don't think we ever actually spoke about this on the air, but we spoke about this after Capella was acquired by IonQ. That, in so many words, IonQ looked like they were looking to just build an end-to-end quantum satellite solution that does everything. And I wholeheartedly agree with you that this is very much sort of a contract that is, if not already core, maybe it's 1 degree off core, but it's very close to what Capella and IonQ are already super competent at doing, and is wholeheartedly an attempt to bring money in and help pay the bills while they continue to build out that quantum end-to-end space solution. I would have expected to see some of that quantum encryption and quantum compute and some of the stack that IonQ is building. I would have expected to start to see some of that materialize in military acquisition and appropriation needs. We haven't seen that materialize yet. I think that IonQ recognizing or getting contracts and getting money, meeting their customers where they are, bodes well for the team and bodes well for the company. It makes me start to wonder if IonQ's vision was potentially sort of, if they preempted the market a little bit too much, if they're creating a solution and building a product that customers don't yet realize they want or need, if that makes any sense. But it'll be fascinating to continue to follow Capella Space. On to a couple of business moves here. First, Zupel closed a $130 million Series B led by Nazca Capital to map the Earth for AI, and they've partnered with L3 Harris to do so. What's notable about this, what's particularly interesting about this, is that Zupel is coming out of stealth after 7 years, and they're doing so with a 115 million euro Series B round. Both of those facts, the duration of time in stealth and the scale at which they're exiting stealth, are incredibly unique. You almost never see them. This would basically align with them raising, if this $130 million raise is in line with some of the other space companies that we see. This would mean that they've raised between 30 and 50 million US dollars in their seed, pre-seed, and Series A raise combined over the last 7 years, while remaining completely behind the curtain and not making any sort of public announcements in doing so. All very atypical.
Yeah, this one is super weird to me. Like, a lot of what they're proposing makes no sense. I feel like they're taking the worst of both worlds of what we talked about with Vantor, and making a company out of it. Like, their stated purpose is to create Earth's system of record, which to me reads like they're trying to create a high revisit, high coverage, high resolution map of the world through Earth observation data. I don't see how that's different from Planet. They are talking about using L3 Harris's advanced payloads, but I don't know why L3 Harris would only sell it to this company. So any other company could come in here and do the same thing. And there are plenty of companies that are already further ahead with spacecraft deployment. The thing that to me makes it seem like they're taking the worst of both worlds is that they're saying that most of their interest is coming from defense players, and that most of their partnership are with defense players. But if their AI is intended to deliver insights off of this capability, then they run into that problem of, like, they own the satellites and the defense industry is suddenly less interested. But then if they go the route of, they could just sell their AI model to these defense agencies, and they can use their own satellites and apply the AI model and get their own insights and have their own sovereignty over it, then they're competing with the likes of Google. Like Google has an Earth model AI. They've been using it on Google Earth for decades, presumably the furthest ahead out of anyone. So it just seems like unless there's some unique combination of their AI and their own constellation, it's just, I don't see what the unique offering is here. And it's odd to me that they're coming out of stealth and still not supplying much information about what they're doing exactly. Just claiming that it's a 2 orders of magnitude improvement upon what we can do. Like that kind of crazy claim, I would love to see backed up by something, by anything that explains what that means and where they're finding that.
Right. I mean, 2 orders of magnitude. That's great. So what does that mean?
Yeah, 100 times better. Like there's not 100 more Earths. Like 100 more resolution, that's just a regulatory problem. Not even like anybody that could do it technically has already figured that out.
Well, my point is that not only is it completely vague, but they're not even describing what metrics these improvements are made in. Like we're still left trying to connect the dots. If they are talking about resolution, like to your point, yeah, that's a regulatory hurdle. If they're talking about power consumption or compute efficiency, like that's great. But if that's what they're referring to, they have to be baselining that off of some very archaic incumbent solutions, because there's been so much improvement in the lag time, latency, and edge compute solutions as well, given the overwhelming trend towards prioritizing insights on the commercial side rather than the entirety of the data stack. But yeah, there's a lot that's unique about this, a lot that's very interesting, and unless we're missing something, I'm certainly left scratching my head a little bit, which tells me that there's probably something that they're playing very close to the chest that they haven't really shared, because they've managed to raise presumably almost 175 million US over their lifetime in order to accomplish this. So there's got to be something there that they're racing towards. They didn't just raise 115 million euro overnight for nothing.
I mean, best I can tell, it's playing in the trend of like Spanish space sovereignty, which has been notably exceptional compared to a lot of other European countries. Like PLD Space had huge funding rounds. Like we're about to talk about them. And like Satellogic, I think, also comes out of Spain. There are numerous Spanish space companies that are very impressive when compared to other European counterparts. And maybe this is just their play at Earth observation capability, but from a sovereign standpoint, in which case I think it makes a little more sense. I still think the valuation is really high. But again, my issue more is that they're not putting anything out there to explain it. It seems very jarring to like come out of stealth at a Series B with that much money for words.
That's a very expensive commodity.
Yeah.
Like if this is a company that's working in a well-established layer of the space industry and they only have commoditized technology, Spain is paying a massive premium in order to stand up that sovereignty. You're absolutely right. Closer to home, Starfish Space has closed a $100 million Series B round led by Point72 Ventures. So I had the pleasure of meeting up with a friend of the show, Alex Hurwitz from Starfish Space, their head of BD and government affairs, at Spacecom in Florida a couple of months ago. And he was pretty tight-lipped about what was going on, but was excited that things were going well and they were making so much progress. So congratulations to them and the team for closing that Series B round. So the raise is to scale their Honor manufacturing capabilities, grow their team, and execute on some of their existing contracts. They have existing contracts with NASA, the Space Force, and the SES, just to name a few. So just a big win and a big announcement from Starfish Space.
Yeah, this is like the polar opposite of Supal. Like they're going into their Series B. They raised less money in their Series B, which is insane because they've demoed some of the craziest capabilities I've seen in space. And to get less money for that in a sector that I would argue is growing more than Earth observation. Like Earth observation is hard to argue as one of the growing sectors. It's big, but it's kind of reached its cap. Whereas RPO is like it's expanding, and the moon's the limit here. The Mars is the limit. So Starfish Space really well positioned. They've had Otter Pup 1 was a really impressive impressive demonstration of the engineering capabilities, being able to recover their spacecraft from a detumble.
You love those torque rods.
I love their solution to it. Just using torque rods to detumble their spacecraft was crazy. Otter Prop 2 is commissioned and ready to go. Like, they have an RPO mission plan. They've got a new target that they're going to pursue. They're going to chase it down over orbits to go tag up with it. And they had the Remora demonstration with Impulse Mirror, which was like another crazy demonstration of capability, because it was their payload feeding sensor data to another spacecraft to allow it to control. So they've demonstrated capabilities amongst just spacecraft control, RPO capabilities, like RPO sensor capabilities. Like, they've demonstrated 2 or 3 different business models they could make money off of that is in high demand, as you noted, across the government and commercial customers. And they have the contract to deorbit a PWSA satellite. So like, they have so much going for them, so much like success already, and just well demonstrated their capabilities that honestly, I feel like 100 million is kind of low. But maybe I'm hoping that it's like they just really don't need that much money. Like, they're doing so well that they just need a little bit extra to get them to that next step.
Yeah, I absolutely love the story of how they got that like approval to deorbit that PWSA. So like the stakeholder that they spoke with, they sort of floated the idea of like, hey, we want to show that we can sort of grapple with and deorbit something. And the immediate response was, how much can I fight you? We're like, which I just love that. I absolutely
crash around.
Yeah. So I'm imagining the whole time just WWE SmackDown on for the entirety of the mission that they were able to demonstrate.
Oh, man. I was imagining like Magikarp uses Splash.
So as we had already alluded to, I mean, PLD Space, the Spanish-based launch company, has acquired 30 million euros in debt investment from the European Investment Bank. This brings their sort of the total financing to date to just about over 400 million US. I think the number that I saw was 438 million. But so PLD has raised a whole bunch of capital, and they've been very well funded. They're in the process of prepping for the launch of Mira 5, which will be the vehicle's inaugural launch. It is partially reusable and is very much a conscious effort to get to full reusability. What I find particularly noteworthy here is that this isn't 30 million in equity. It's not 30 million euro in equity that they've raised. It's debt. It's venture debt. And venture debt in space is something that we very rarely see. So to share a little bit more about venture debt sort of briefly here, it is about 50 to 100% more expensive than traditional commercial debt. So you're looking at sort of an annual, or you're looking at, somewhere between 10 and 15% cost. And that's more expensive than you'd get for a commercial sort of bank loan, right? But the way that equity works, and the way that the sort of the cap table and the cap stack works, is that debt is always preferable to equity for the founders, for the most part. Just the way it works, if you go out and you raise equity, everybody who already owns equity in the company gets diluted a little bit. So even though the value of the company goes up, if we were to raise equity, our ownership in the company would go down. So, our 100 shares would constitute 8% ownership instead of 10% ownership after raising a little bit of equity. But if we raise debt, we get to keep that ownership. The trade-off, the difficulty with that is that, well, now you have debt that you need to service. So by taking on debt, by raising that additional capital, now you have this debt expense. So you've increased, whatever the we'll say it's 10%. So 30 million means they got to come up with 3 million euros a year to service that debt and to pay that debt down. And so, you can really read it in a couple of different ways. You can read this as either a really positive signal because they're in a situation where they're able to actually raise venture debt. Venture debt is really hard to come by, especially in space, because space is so risky. So you could read this as a really positive signal that the European Investment Bank views them as de-risked enough to qualify and be worth assigning a debt to them. You could also view it in a positive light because, sort of as we'd alluded to, there's a big prioritization for sovereign capability. And so EIB could very well just like, hey, look, we're with you, we're backing you. And so we're going to make sure that you succeed. So you could sort of view it in that light as well. But sort of out in the wild, venture debt can also be viewed sort of in a negative light, in a negative signal, because venture debt is typically pretty expensive. And if you're raising venture debt, sometimes you do so as an alternative to raising capital. Most folks would prefer to take on debt rather than equity, so that they're not diluting anything. But you're only going to be able to raise about 10 or 15% in debt, what you'd be able to raise by selling capital. So, you could view it as like oh shoot, they're really up against it. They desperately need capital. They're going to raise whatever they can, and they're going to take on some venture debt here. Big picture, I think what we're looking at is a pretty positive signal that PLD is in a healthy spot and is de-risked enough to warrant a debt position. And this is off the back of, I believe, a $150 million raise or $130 million raise, but they closed a pretty substantial round of funding back in March, fairly recently. So it's very unlikely that PLD has already run out of money and that they need to go out and achieve more financing in order to get Mira 5 up. What's much more likely is that they came across the opportunity to acquire some quote unquote free money, some money without any dilution to the stakeholders or shareholders. And so they're in a position where they're confident that they will be able to service the debt without consequence.
Yeah, I mean, I think it's great to see PLD get some more money. I think they're doing real well. They're working towards their inaugural launch, so we'll know more once they finally launch. But they're one of my favorite rocket companies. I really like that they're building out their capabilities in Spain, because they're not one of the primary space kind of companies or space countries in the EU. So to have their own sovereign launch capability would be really cool, especially since they're supposed to be getting their own spaceport pretty soon. The El Hielo spaceport out in the islands in the Atlantic. So it would be a really neat capability. I think any money they can bring in to get themselves there is great. I know that the EIB is something we talked about back in November because it had kind of just formed at the time. They allocated 500 million euros to space investment, and we've seen it slowly trickling out over the months. Like last month, we talked about OQ Technologies. They got a similarly sized debt investment to develop their direct-to-device capability, and now PLD Space is getting this for launch vehicles. So it's good to see that Europe is standing up different forms of investment to prop up their space industry. And I like seeing that it's being distributed amongst multiple countries as well as multiple different sectors in the space industry, because it feels like a well thought out approach to developing the core and cutting edge technologies that Europe needs to kind of bridge the gap that's been growing between them and other spacefaring nations.
So additionally, Portal Space raised a $50 million Series A. This was led by Geodesic Capital and Mach 33. The raise is intended to continue the development and manufacturing of their spacecraft, which they've optimized from sort of the ground up for high mobility and high delta V operations. It's something that we spoke with Harrison Box from Paladin Space about fairly extensively. They were very excited to be partnered with Portal Space and to be able to be sort of the payload on that vehicle, on that very impressive vehicle. So they are doing this off the back of a $17.5 million seed round that they raised back in 2025, which, if you'll recall, we've spoken a couple of times. There have been a couple of different $10 million seed rounds that have come through this year that are really impressively big. So 17.5 million is one of the biggest that we've seen in the space industry. So 17.5 million less than a year ago, 50 million this week. They've raised a heck of a lot of money and have been developing and delivering in very rapid succession. And the need for the capabilities that they offer falls pretty closely in line with some of the RPO and defense security needs that we're seeing. The premium and prioritization of high delta V, high mobility is definitely one that has a high correlation to the needs of national security.
Yeah, this company is super cool. Like you said, we talked to Harrison Boggs. We also talked to Trevor Smith. They both partnered with Portal Space to use that high mobility platform for some really cool applications. The technology that's core to their company is being developed to be a solar thermal propulsion system, which is rare to the point that they will be the first to commercially do it. NASA has tested the concept before, but this is the first company that's actually going to fly it. I've seen other companies like TransAstra kind of take the same approach with like water based thrusters, but Portal Space System is using ammonia heated by reflected rays from the sun to give them high thrust capability. Super cool tech, super advanced. If anybody can do it, Jeff Thornburg can. He's the guy that developed the Raptor engines for SpaceX. So great background there to develop out this capability. Honestly, I'm surprised they didn't get a Series A earlier. They've been at this a few years, but I think the inciting incident here might have been that they just launched their first hardware to space, the Mini Nova aboard Vigoride 7 on board Transporter 16 last week. So to me, I think that was like a gate that once they crossed it, they were like, all right, now you can have your money. And with that money, I think it's great. They've got Starburst 1 going up later this year. I think it'll help propel them through that checkpoint and hopefully on to many more exciting missions in the coming years because the partnerships they have are super cool. I think that it's a great capability. Again, if somebody's going to figure it out, I'm sure they can. And I just can't wait for this to be a new kind of propulsion system on orbit.
Speaking of money, Hawkeye 360 has filed to go public. So they're trying to get as much of it as they can. This is off the back of their, I believe, $150 million Series E raise from back in December. They conducted that Series E so that they could acquire innovative signal analysis, and they've now formally filed for an IPO. The IPO filing reveals how much of a turnaround 2025 was for the company. They saw a almost doubling of their revenues, a 74% jump, and a swing into profitability. They now have a roughly 1.8% net margin. So 114 million in revenue with just over 2 million in net revenue. And so the second that they've gone profitable, the second they've gone positive, they're looking to sell and looking to get out of the market, which is comical to me. But joking aside, this is the third major IPO announced or suggested this year. So we've got York Space, we've now got SpaceX and Hawkeye 360. And the IPO is intended to sort of service and pay back some of the debt that they currently have on their books and to fund some of their future acquisitions. So their Series E raise from back in December was valued at, I believe, it was 150 million at about a $2 billion valuation. So they're going to be looking for some sort of step up on top of that, given that 2025 was such a big success for them. So I wouldn't be surprised to see a target valuation in the neighborhood of somewhere between $3 and $5 billion in their IPO. But they'll be looking to raise a whole bunch of money with that to go out and shore up their debt position, make sure that they're not over leveraged, and to acquire and integrate more capability as well.
Yeah, I'm assuming you're only counting American IPOs because we just mentioned Space T going for their IPO.
Well, I'm counting IPOs that will be available in the on the NASDAQ. Yeah.
Yeah. Okay. Because China's been on an IPO tear as well. I think we mentioned Space like a couple weeks ago.
Yeah.
So just a hot year for the space market, which I love to see. Hawkeye's been around for a while, so good for them going for that IPO. I like it that it's not just like like Starfighter where they like kind of stealthily immediately IPO kind of thing. So they've got some great assets on orbit. I feel like they launch satellites every on every rocket. And the need for ISR intelligence signal surveillance and reconnaissance is growing, and they've got a fleet that can meet that demand. It's been traditionally poised for maritime applications, but I think that the demand for it across many different defense domains is growing, and they're poised well to capitalize on that. So on tech advances for this week, I got one I wanted to include, which was this IEEE paper I saw that was really neat. It was proposing a concept for over-the-air compute. And not by concept. It's been tested, so it's more of it's possible, but it hasn't really been deployed at scale. I thought it had really interesting implications for some of the communications constellations we're seeing, as well as orbital data centers. The concept behind it is that with traditional compute networks, you have to send data from one computer to another, and then it gets processed there. But what this team demonstrated was their ability to do computation through the RF signal itself. So by using a specific timing algorithm that allows all the signals to combine and operate on the same modulation, it's able to use the interference of different radio signals to perform the math as the data is being transmitted over the signal. So certain like ranked choice capabilities for AI training, certain computational additive operations that are used for a lot of sensor fusion can be done using this protocol. And so to me, it's really interesting when we talk about companies like Aspect Aerospace last week that has like hundreds of small satellites all communicating over RF to create one large fused sensor, could leverage capabilities like this. When we talk about orbital data centers that are using multiple different nodes to calculate something, being able to have them operate this way would save them a lot of power. And that's kind of one of the things I've been looking for a lot in space, is that the reduction in the consumption of power for AI models and their supporting systems is one of the key knobs that's yet to be turned to reduce the difficulty of doing that sort of application. So I think this is an interesting concept that's being explored that could potentially assist there as well.
Well, that is a wrap for this week's recap of the space industry. We certainly hope you enjoyed the episode, and as always, please drop us a comment, check out our socials, and follow us on Spotify, Apple Podcasts, YouTube, Substack, or wherever you're receiving this signal. Until next time, this has been Paul Mayer and Harrison Lambert, signing off for now.